Formula One is the top category of world motorsport. It is known for being the pinnacle of automotive engineering, where teams like Ferrari, Mercedes, among others, compete with the highest technology cars meticulously built on closed circuits around the world. In fact, Formula One cars are so advanced and have such incredible engineering that they are capable of reaching speeds that exceed 370 kilometers per hour. That's considering these cars weigh only around 720 kilos, thanks to their chassis and bodywork being completely made of molded carbon fiber, which is a synthetic, lightweight, and strong material. In addition, these cars can go from 0 to 100 kilometers per hour in just 2.6 seconds, which is extremely fast. And during tight turns and hard braking, the driver can experience a force of 6G, that is, 6 times the force of gravity, a powerful force that can harm internal organs and cause dizziness, disorientation, or unconsciousness. That's because Formula One cars are the only ones in the world capable of taking certain types of turns at 300 kilometers per hour safely. Contrary to popular belief, Formula One isn't just the world's biggest car race. It's the largest engineering competition and a showcase for ongoing vehicle improvements worldwide. That's because Formula One cars are entirely built by their own teams, but they have to follow a series of rules established by the governing body, the International Automobile Federation, or International Automobile Federation. That's where the name Formula comes from, meaning a set of established rules that constructors must follow when building their vehicles. No two Formula One cars are exactly alike. Engineers are continuously and tirelessly spending millions of dollars to develop and look for any engineering solution to improve the car's performance and secure an advantage of a few milliseconds or seconds over their rivals. That's why the sport is so renowned worldwide. To give you an idea, the disc brakes found in all cars today are an original invention from Formula One. The semi-automatic transmission, the famous paddle shifter, is also an original invention from Formula One. The multifunction steering wheel, parking cameras and sensors, and turbochargers are all technologies that originated from Formula One. That's why there's a certain secrecy surrounding the anatomy of the cars. The speed reached by these cars is so great that if it weren't for the heavy and advanced engineering solutions developed and implemented exclusively for them, they would simply be impossible to control. Besides the fact that they would go flying through the air completely out of control. The design implemented in Formula One cars requires, among other things, that the airflow passing over the vehicle be directed in such a way as to generate downforce, that is, a downward force that presses the car to the ground. It boosts tire grip on the ground, unlike the lift force in airplanes that takes them off the ground to fly. Formula One cars generate downforce in 3 ways. By the car's floor, which has air passages called Venturi tunnels that produce an effect of the same name. When the airflow passes through one of these paths, which have varying widths, it is accelerated. When air accelerates under the car compared to above, it creates a low pressure zone, generating suction. In this way, the car is pulled downward and stays closer to the ground. And that thing that looks like wood down there is called jabrock. It's a resin consumable that maintains ideal ride height, thus preventing the car's floor from touching the ground. If the car's floor touches the ground, the car can lose all or part of its downforce and become uncontrollable. This part, which is made and installed on the cars by the International Automobile Federation, is mandatory, and after the race, it is inspected to see if there was too much wear on it, which indicates that the car is too close to the ground, which gives grounds for the team to be disqualified. The second way to generate downforce is through the front wing, where the air meets the car's aerodynamic surfaces for the first time and helps keep the front wheels glued to the ground when entering and exiting corners. And the third way is through the rear wing, which has a specific upward angle and causes the air passing through it to be directed upwards. And as a reaction, aerodynamic pressure is generated. That is a force pushing down. The downforce and aerodynamic pressure really is a force. That's why the International Automobile Federation controls and conducts rigorous tests to prevent teams from installing rear wings that could slightly lower their angle at certain speeds, thus generating less drag and consequently giving the car a considerable speed advantage over the others. In this video, you can see how much the Formula One car lowers due to the enormous amount of downforce generated by the set of wings on the car at high speeds, which results in greater grip on the straights as well as when entering and exiting corners. That's why Formula One cars don't flip or roll over, even when taking corners at 80, 150, or even 200 kilometers per hour. But of course, design also matters. To give you an idea of how strong the downforce is on Formula One cars, in 2023, the driver Carlos Sainz, who was doing a qualifying lap a day before the tournament, drove over a manhole cover on the track at such high speed that the ground effect generated by the car, which creates the downforce, caused the manhole cover to be ripped out and sucked up. This caused serious damage to Sainz's car, which led to the session being canceled. In fact, Formula One cars generate 3 to 4 times their own weight in downforce. That's while they're at high speeds. And since Formula One is all about high speeds and with that big and heavy crashes, sometimes even fatal, a set of safety criteria must be strictly followed, not just by car constructors, but also by the driver and racetrack staff, in order to ensure the highest safety standards for the event. Starting with the driver's clothing, where it is forbidden to wear any kind of underwear, such as boxers, that is not made of fire-resistant materials. Wearing any jewelry or piercings is also prohibited. Drivers must only wear the base layer, which can be shirts, pants, balaclava, and socks. Everything is made of Nomex, including the racing suit, which is a fiber resistant to heat and fire, capable of withstanding temperatures over 800 degrees Celsius for more than 10 seconds, allowing drivers enough time to escape in case of fire. They must also wear a helmet, gloves, boots, and head and neck support. It's an abbreviation for head and neck support, which serves to protect the head and neck in case of impact, reducing the risk of serious injuries. Formula One cars use about 46 liters of gasoline per 100 kilometers, unlike the approximately 8 liters per 100 kilometers driven by a regular car. This means that Formula One cars consume 2.3 liters per kilometer driven, unlike the approximately 10 to 12 liters per kilometer driven by a regular car. Since the racetrack averages 305 kilometers and Formula One cars hold up to 140 liters, this means that to complete the circuit, they needed to refuel a few times as well as change tires. And that's where the pit stops come in. Performed on average in less than 2.2 seconds, with the current world record being 1.80 seconds. Pit stops are nothing more than a short mandatory stop that drivers must make to change tires and perform some repairs. However, much more can be done during these short stops, such as changing the front wing, changing the suspension, repairing the floor for damage, changing the brakes, restarting the car's electronic system, and even changing the rear wing. This is among the most complex and lengthy repairs. Between 40 and 60% of the car can be changed or repaired in less than 3 minutes, which makes pit stops a true contest of engineering and agility. Every second counts and can mean victory or defeat. To begin with, since 2010, the International Automobile Federation has banned refueling during pit stops, making teams put enough fuel in the cars for the entire race. This was done because of the high costs of fuel, but mainly due to recurring accidents involving serious fires during the refueling phase, in which the hose would get stuck to the car and when forced to disconnect, fuel would spill and start a big fire due to contact with hot areas of the engine. At other times, the driver would take off before the hose was disconnected, and this would cause it to break and fuel to spill all over the pit area. Therefore, pit stops are currently only for tire changes and repairs. But how is that done? When entering the pit lane, the area where pit stops occur, a team made up of about 22 people, including mechanics and engineers, will work on the car simultaneously. First, 2 mechanics use hydraulic jacks at the front and rear of the car to lift it. At the same time, 12 mechanics are focused on the tire changing process. Each tire has 3 mechanics. One will loosen and tighten the single nut that holds the wheel, using a pneumatic gun. One mechanic will remove the old tire, while another installs the new one. 2 engineers remain in the car's center to hold and stabilize it while it's on the jacks. They are also responsible for cleaning radiators, the visor, and mirrors when needed. There are also 2 people positioned at each front corner for front wing adjustments. And finally, 1 crew member supervises the pit stop and the pit lane traffic, with the final say on whether the pit stop gantry system can turn green and the car can be released. There's also a second team member reviewing the stop from the side as another pair of eyes. They can also stop the light from turning green if a problem is detected. When the green light comes on, the wheels are secure. Pit lane is clear, so the driver can accelerate and exit the pit box. However, there may be more crew members, like 2 extra mechanics with hydraulic jacks in case something happens to the main ones, and other engineers who can step in if the car has suffered more severe damage. In addition, in the past, there were 2 more people responsible for refueling. All this is done perfectly in just 2.2 seconds. The main reason for pit stops is the tires, which the regulations require teams to change at least once, except when it is raining. All Formula One tires are manufactured exclusively by Pirelli and are essential for the car's performance. They are more resistant and durable than regular tires because Formula One cars reach higher speeds and endure much greater stresses. There are 2 types of tires in Formula One: dry weather tires, also known as slicks, and wet weather tires, also known as cinturato. Dry weather tires are classified by softness from C1 to C5, with C1 being the hardest and C5 being the softest. C1 tires are harder and wear out less, so they need to be changed less often. However, they offer less grip and are therefore recommended for tracks with fast and smooth corners or high temperatures. C5 tires are softer and therefore offer greater grip on the track. They're recommended for tracks with tight corners but require more frequent changes. Meanwhile, Cinturato tires for wet surfaces can be either intermediate, green, or full wet, blue. In Formula One, peak tire performance occurs at about 100 degrees Celsius. Below 85 degrees, the tire is considered cold. The rubber becomes harder and extremely slippery to drive on, which makes braking more difficult. Above 110 degrees Celsius, the tire gets too hot and the rubber wears out quickly, causing blisters to form on the tire. Also, the car becomes just as slippery. It's worth remembering that before the race, for safety and performance reasons, the tires are kept in a thermal blanket, which keeps their temperature around 70 degrees Celsius. Each tire costs about $630, so for total around $2,520. And you can't talk about Formula One without mentioning the controversial part, heavily criticized for its appearance, but which exists for the sake of safety: the halo. The halo is an arc-shaped safety device that protects the heads of Formula One drivers in case of a collision. It's a curved bar that surrounds the driver at 3 points, front and both sides. It can support the weight of a London double-decker bus, which is about 12 tons. That's because the part is made of grade 5 aerospace titanium. The halo is the strongest part of a Formula One car and weighs just 7 kilograms. It was created to prevent objects like debris from accidents, tires, or other cars from hitting the driver's head, which could be fatal. It also protects the driver's head in case of a rollover. Despite its clear advantages, the device was not well received when introduced in 2018. Mainly for aesthetic reasons. The device is not made by the competing teams, but rather, it is delivered to each of them by the International Automobile Federation, which oversees CPTEC, the company chosen to produce the parts. The Halo is credited as being directly responsible for saving the lives of drivers like Max Verstappen and Lewis Hamilton, Romain Grosjean, Zhou Guanyu, among many others. By the way, did you know that before the Halo, they considered putting a canopy identical to those on military fighter jets for better protection in case of accidents? That's because theoretically the part would be closed and offer more protection, being able to repel large objects like tires and even engine parts without breaking, besides being more aesthetically pleasing. However, the idea didn't move forward precisely because the part offered too much protection, which would make it terribly difficult to break in order to evacuate the driver in serious accidents, especially those involving fires. And speaking of fires, I've always wondered, how can a car made of carbon fiber, which gets destroyed under moderate impacts, be considered a safe material to build a car that reaches 370 kilometers per hour? In practice, Formula One cars are made of carbon fiber because it offers an exceptional combination of high strength, rigidity, and extremely low weight. This makes it the perfect material for races where every gram counts and maximum speed is crucial. Essentially, the fiber allows for the construction of a very strong car while keeping the total weight as low as possible. And when it comes to destruction in accidents, the flexibility of the material significantly contributes to absorbing the tremendous energy of the impact, thus contributing to the driver's safety and survival. This significant destruction of the cars in accidents is directly responsible for the lower occurrence of fatalities. To get a sense of how well-made and strong Formula One cars and their survival cells are, in 2007 at the Canadian Grand Prix, Robert Kubica's car hit Jarno Trulli's Toyota, damaging the front wing and causing him to lose control. The car hit a bump, lifting the nose and stopping Kubica from steering or braking. The car crashed into the concrete barrier at 313 kilometers per hour, then rolled across the track and struck the opposite wall. The impact was so strong that the survival cell broke, exposing Kubica's feet. The impact measured 75 Gs, but he still had only minor injuries. In other words, Formula One is much more than just a simple car race. It's an arena where automotive engineering is pushed to and often beyond its limits. It is the only tournament where months of work and a lot of secret engineering are put to the test in search of 5 seconds or thousandths of a second of advantage to win the race. Just to remind you, I have only scratched the surface of everything there is to say about Formula One. I left out major pillars of this sport, like the aerodynamics of the cars, the secrecy surrounding the mechanical parts of the cars, the fact that you can survive a high G-force crash in Formula One, but this rarely happens in other fields, unlike the cheating often seen in sports and other critical issues. But I will address them in due time.